Welcome to Lab 2, Traffic Generator, Sync, and a Hub. The aim of this experiment is first, working with Seagate, second, network hub, traffic generator, and sync, third, connecting any net source files, and four, random numbers in Omnet. First, open up source file, add new file, and we select source file. We can create hub.cc file. Click Finish, and hub file will be created. As hub header, we can include the omnetpp.h class hub public C module protected for initialize for virtual void handle message C message asterisk message virtual void finish. Which contain input in and input out, and click Save. On the source file, click New and add another net file on the source project. We can create network2.net and simply net file and create net2 as the network. Click Finish, and we can create our topology inside the boxes. Add one node and one hub inside the box. As connection, we must put on hub to the node. Hub out to node in the single arrow. Next, move on to the source tab, and we have to edit some of the program which contain display, hub node, and hub out to node 1. Click Save. Now, we move on to ini file. Create omnetpp ini file, empty ini file, and browse node, simple node, or net2 network try source.net2. Click finish, and we can add on the time interval that required for the experiment. On the source file, click Omnet PP2, run as one Omnet plus simulation, and click OK. Wait until it runs till 100%. Click Run until 100 simulation time to stop at. Click OK, and you can run with full animation. As we can see, all the messages are running into the hub and outside to the node, and the information are tabulated inside this table, and we can click OK to see the simulation running. Click on Result under the source file, General SNF. Click Finish, and under the Browse Data File and Scalar tab, we can see all the value of the receive file and the send message are required. Number of received message, number of send message. Click Node.net we can include parameters, the time interval. Declare double time underscore interval, and gates, input in, and also input out. Don't forget to save it. Next, move on to node.cc, which we can manipulate the time interval inside the coding. From 0.1, we can change it into par in bracket time interval, and we save it. Move on to Omnet pp2ini. We can include config the interval with respective number. Click Ctrl B to build up the project. Wait until it's running 100% simulation mode, please. And we can run the source. It looks like something like this. Click OK, and there we go. One hub and 5 nodes are interrelated to each other. Run the animation, and we can see the same message are going randomly with the time interval taken. You can build up all the information and transfer to the result. The interval, click, source, and finish. Under the browser data, click Scalar tab, and we can see the number of received message, number of sent messages are different from the previous month. We also can add on another coding in the Omnet pp2, which is config trandom. Click Save and Ctrl B. Run the project, and we change it into T interval 2. Click OK, and set up 100 time interval. Click Run, and we can see the random number that we include in Omnet pp2 is functioning on our topology. Click Stop to read the data. We can build up the data inside the result T interval 2. Open up under the source project and finish. As we can see, inside the Browse Data tab and the Scalar tab, the different number of received messages and number of sent messages differ per node compared to T interval 1 and the general one. That's all for today. So we can compare all the time and the value of the messages transferred per packet. What we get something about gates, working with arrays in gates and modules, and we can interacting between .cc, .net, and .ini files. And we also get multi-configuration in ini files and something about random numbers. With that, I thank you.